In this video, we're going to start off with a problem. Below is a sphere with a radius of 4. And how do we find the volume of the sphere? Well, it seems like what we're going to need is a formula to actually calculate that volume. But again, we're not just going to give you the formula. We want to develop it and see where it comes from. So we're going to start off with a little bit of a sketch. Now, we're going to pay close attention to this. What essentially we're going to do is we're going to take a sphere and we're going to peel off the layers of a sphere. And then we're going to stack those layers on top. What's going to end up happening is when we peel away the layers of it, we're going to now have smaller and smaller and smaller spheres until eventually what's going to happen is we're not going to have a sphere at all. It's just essentially going to disappear. So let's take a look at what happens when we start this sketch. So we're going to take our first layer and just kind of peel it away. There we go. It's going to take a little while because it's a very intense diagram here. So if you notice, we've peeled away one layer so far. Now we've peeled away another. And each successive layer is going to give us a circle. And as we stack those circles, we'll notice that those circles are getting smaller and smaller and smaller. And they eventually start forming a larger shape. Now, let's think back to that first layer as this is still going through. Each layer that we peel away represents the surface of the sphere. We already know the formula for the surface area of a sphere is 4 pi r squared. So each of those circles that we're peeling away is 4 pi r squared of that remaining sphere. Now again, once we keep peeling this away, and it looks like what we end up getting is a cone shape. As it keeps peeling away there until we're almost quite done. I think we're just about there. So I'm going to move this around a little bit. And you see here that we definitely have that cone shape to it. If we look from the top, it's also a cone. From the side, and the bottom. And all those different shapes indicate to us that we definitely have a cone. Now each of these, again, circles is going to be a 4 pi r squared with a different radius. But our original radius was this bottom one here. We had a radius, an area of 4 pi r squared for that base. Now in the video that we looked at previously, we found the volume of a cone. And the volume of a cone was 1/3 the area of the base times the height. So by peeling away all these layers of the sphere, we've really transferred that volume into a cone. Took the volume from the sphere and made it into a cone shape. So to find the volume of this cone that's left, we find the area of the base. Wait, we know the area of the base. It's 4 pi r squared because it's that surface area of the sphere. And to find the height, I'm just going to drag this down. And it might be difficult to see, but we've matched that up, that point right there up. And kind of move this around a little bit. The height of that cone is just going to be the radius of our original sphere. So let's develop the formula. First, what's the area of each peel? It's not just pi r squared, it's 4 pi r squared, because we're dealing with the surface area of the sphere being the area of that first peel. And then each peel after that is still 4 pi r squared, but it has a slightly smaller radius every single time. As more layers are peeled away, what solid is beginning to form? We form a cone. And the height of the new solid form, we just showed in that diagram right here, as we move that around, the height of that cone is going to be the radius of the sphere. So putting this all together then, when we're finding the volume of the sphere, we're going to take 1/3 the area of the base, so that's what this is right here, the area of the base, times the height, and then we simplify that. So r squared times r is going to be r to the third, we have pi, and then 1/3 times 4 is going to give us 4/3. So our volume of a sphere, we can use this formula any time now because we have it, but we want to know where it came from. It's going to be 4/3 of pi r cubed. So take your radius and cube it. So on these problems, we'll just run through one or two real quick because I think they're pretty straightforward. We're going to find the volume of these spheres. And when we find our answer, we're going to leave our answer in terms of pi. And where appropriate, we're going to include units in our answer. Nice thing is if the radius is a multiple of 3, we know that we're going to get a really nice number for our final answer. So let's take a look how we would actually enter this in. So number 5, we have 4/3 pi times 3 cubed. So here's how I would enter this in. Now I want my answer in terms of pi, so I'm not going to actually put the pi in there. What I'm going to do is take 4 divided by 3, and then times 3 to the third power. And to do an exponent, I hit the caret key, which is above the division symbol, and then I would hit enter, and I'd get 36. What that means then is my volume is 36 pi cubic feet. A little bit more challenging when we have a 14, and I'm going to show you why when we type this in our calculator. Well, things get a little bit hairy. So I take 4 divided by 3 times 14 to the third. And when I do that, oh man, that's what I get. 365. Okay. Well, I'm going to try and turn that into a fraction because we prefer the fraction as opposed to the decimal, just for sake of ease here. So I'm going to go to Math Fraction, and I'm going to hit Enter, and it will convert it for me. It'll take that decimal that we have right here and then convert it into a reduced fraction. 10,976 thirds pi. So that would be our volume of this sphere here. Now again, if we give you a diameter, you would need the radius. So to find the radius, if you're given the diameter, you're just going to divide that by 2. If we give you something like a hemisphere, unlike surface area where we had that new surface that we had to account for, it's not a real big deal for a hemisphere when we're dealing with volume because we just want what's inside. So we could, in theory, just take the volume of the entire sphere and then cut that in half because that's exactly what a hemisphere is. It's a sphere that's been cut in half. Think of the western hemisphere and the western and the eastern hemisphere of the globe, or the northern and the southern hemisphere. It's the same basic idea. It's just half of that sphere. So again, the volume formula for a sphere is going to be 4/3 pi r cubed. Just a matter of taking that formula, plugging in, and simplifying our fractions wherever we possibly can.